Okay, sum and difference formula for tangent. So you want to take tangent of two angles added together, two angles subtracted. Tangent of A plus B is equal to tangent of angle A plus the tangent of angle B divided by 1 minus tangent of angle A times the tangent of angle B. Okay? So that's the difference between the top and the bottom. Top is plus, bottom is minus. If it was subtraction of two angles, then we would put a minus sign underneath there, and a plus sign underneath there. So you can see they are opposite in terms of sign. All right, flip to your second to the last page. Here's your formula right there. It's located with the sine and cosine sum and difference formulas. This is where we're going to spend some time today. We're going to teach you how to do the tangent, and then we're going to move on to some other formulas in a second. Okay, so I'd like to do problem number 3. Find the exact value of tangent of 19 pi over 12. Who has an idea what to do? Sure, let's put it into degrees. So we'll take 19 pi over 12. We'll multiply by 180 over pi. The pi's cancel. 180 divided by 12 is 15. We get 285. So what we want is we want the exact value of tangent of 285 degrees. So I need two angles that either added 285 or subtracted 285. Angles whose exact values we know. Sure. 225 plus 60. To do that, you see another option. 240 plus 45. 315 minus 30. 270 plus 15. The only trouble is we don't know the exact value of tangent. So you have lots of options here. Also put up 345 minus 60. Okay, there's lots of options to choose from, so you have to be able to come up with one. I would like to use 225 and 60. However, for the sake of this problem, trying to show you some issues that you're going to encounter in your assignment, I'm going to choose 315 and 30. Okay? So I'll rewrite this as the tangent of 315 minus 30. Now I use my formula. If it's minus in the formula, what is it on top? Minus what is it on the bottom? Plus. We have the tangent of 315 minus the tangent of 30 divided by 1 plus the tangent of 315 times the tangent of 30. Okay, now I I need exact values. So I'm going to make a unit circle. Again, you got to come up with these exact values on your own. You got to be able to construct these triangles. 315 looks like that. We know the terminal point for 315. Root of 2 over 2. The second one is negative, right? Is tangent x or y divided by x? Y divided by x. If you divide them, what do you get? Negative 1. So therefore, the exact value of tangent of 315 degrees is equal to negative 1. Okay? Now I'll make a 30-degree angle. Anybody know the terminal point for a 30-degree angle? Root of 3 over 2, 1 half. So tangent is 1 over x. If you take 1 half divided by the root of 3 over 2, 1 over the root of 3, or root of 3 over 3. There you have it. Now, if you can begin to try to memorize those terminal point values, you can see how it can make things a lot easier, right? You know how to construct it. I will say I don't have nearly as many people in calculus or in trigonometry that are able to come up with those values as quickly as what you would probably want to. So. All right, so now we just plug in the values, and then we've got a decent amount of simplifying to do. So tangent 315 is negative 1 minus tangent 30 is the root of 3 over 3 divided by 1 plus negative 1 times root of 3 over 3. So it would be minus root of 3 over 3. What kind of fraction do I have? Starts with the C. Complex fraction. How do we simplify a complex fraction? Yep, we find one fraction in the numerator, one fraction in the denominator, and we multiply by the reciprocal. So what's the common denominator? 3 for both the top and the bottom, correct? So I will end up with, hey, negative 3 minus the root of 3 over 3. Lots of 3's in this problem. Divided by 3 minus the root of 3 all over 3. Multiply by the reciprocal. And the 3 is canceled, leaving you with negative 3 minus the root of 3 over 3 minus the root of 3. What to do now? We cancel, cut our fingers off, so what should we do instead? Starts with the C. Let's do the Spanish. Conjugate, multiply by the conjugate. We need to get rid of the square root of 3. Okay? What did you see? It's all right, bud. Okay. So that YouTube can hear what? What did you see? King Sierra? What? King Sierra. Oh, okay. But it starts with a Q? So the Q? Okay. Wow. Okay. All right. Thank you. Good try. Conjugate. That's what we want. So what is the conjugate? 3 plus the root of 3. I'll distribute and multiply all terms. Negative 3 times 3. negative 9. Negative 3 times the square root of 3 is negative 3 roots of 3. Negative root of 3 times 3, negative 3 roots of 3. What is the negative root of 3 times the positive root of 3? Negative 3. 3 times 3, 9. 3 times the root of 3 and 3 times the negative root of 3. That's the whole idea, right? The whole idea is that the conjugate will make the middles disappear. So then we have the negative root of 3 times the root of 3 is negative 3. Negative 9 and negative 3 makes negative 12. And then minus 6 roots of 3 all over 6. We get negative 2 minus the root of 3. That's the exact value for the tangent of 19 pi over 12. Stressful. We need a little stress, it looks like. It's the denominator. We wanted so the conjugate is just a change in sign. No, you don't multiply through by negative 1. You simply change the ending. So just like in Spanish, you change the ending. In math, we change the ending from minus to plus. That's it. Okay. Okay, let's do a proof. Megan's excited. She wants to do a proof, and so we will. We are going to prove a cofunction formula. If you flip to your very back page, your second to back page, you can see that there are certain cofunction identities. What do these mean? I will show you an example of what they mean. What graph is the red graph? It is the sine graph. What graph is the blue graph? It is the cosine graph. Would everybody agree with me that the cosine graph is the same as the sine graph, just shifted pi over 2 units to the right? Okay, so we're not going to go through and necessarily prove each one, but cofunction properties are true. So sine can be written as cosine, and cosine can be written as sine. It's not too difficult to be able to do. As you can see here, these cofunction identities state that the sine of pi over 2 minus your angle is equal to the cosine of the angle. And so you can see the relationship between those two, between tangent and cotangent, between cosecant and secant. All right, so what we're going to do is we're going to try to prove this one right here. We're going to prove it using our sum and difference formulas from right here. So this sounds bad. It's really not that challenging. So I'll show you how it works out. Instead of tangent, I'm going to do a little trick here. I'm going to choose to use sine of pi over 2 minus u times the divided by the cosine of pi over 2 minus u. Now I'm going to expand these into our sum and difference formulas. So this is a difference formula for sine and a difference formula for cosine. Remember the difference formula for sine? We said sine of the first angle times cosine of the second angle. And if it's minus here, it's minus there. And then we switch them. We do sine of the second angle and cosine of the first angle. Again, you get that formula sheet on the test, but you have to be able to access it and remember it. Divided by cosine of that. Well, cosine it's cosine right away. Instead of a minus, it turns to plus. And definite sign. I'm going to pause. Does anybody need any clarification as to how I came up with any of those pieces of reports? Yo. Yeah, so what I just, did you see the sine over cosine as tangent? Okay, so then this is like sine of angle A minus angle B is sine of angle A cosine of angle B minus sine of angle B times the cosine of angle A, right? So I just chose A to be pi over 2. So I plugged in pi over 2 for A, and then cosine of A, I have a pi over 2 there. And I chose B to be U. So I put the U there, and I put the U there. Same thing with the cosine. Then I would write out the cosine formula where pi over 2 is A, and U is B. So I had to take our lesson from last week, Tuesday, and throw that stuff together. All right. Now, I don't know the exact value of sine of u or cosine of u, but I do know the exact value of sine and cosine of pi over 2. If you take pi over 2 and write it like this, okay, pi over 2 is 90 degrees. What is the coordinate right there? 0, 1. Which value is cosine? The x value. Which value is sine? So therefore, sine of pi over 2 becomes not sine of 1, but just it is 1. So you have 1 times the cosine of u. Minus, over here, I have sine of u times the cosine of pi over 2. What's the cosine of pi over 2? 0. So you get sine of u times 0. Divided by, what's the cosine of pi over 2? 0 times the cosine of u plus the sine. What is the sine of pi over 2? 1 times the sine of u. All right, what happens? Right? So you end up with yeah? 0 times cosine is 0. So therefore it goes away. Okay, I will give you your assignment here. There is the assignment.